All right, gang, pretty cool video here. At least I think it's kind of cool. What I'm going to teach you here is I'm going to teach you how to get a data set from StackCrunch into R to analyze it and make the same calculations that we did in StackCrunch. And again, here's what's going to happen. Some of you are going to, well, some of you are not going to like StackCrunch or R. Some are going to like StackCrunch better than R. Some of you will like R better than StackCrunch. And some of you will say, whatever, kind of understand them both. I really don't have a preference. I can use either. That's what's going to happen. Trust me, I've been teaching 35 years. I've been teaching statistics almost like nonstop since about, I don't know, 1998 or so. So I just know that's just what happens. So I want to give you options. So, got a lot going on here. First of all, I've got four things open. I have Excel. I have the Word document where the values that I found for using StackCrunch for this data set arsenic. And, I have the data set here. So what I want to do is I want to get this data set into Excel, save it on my desktop, get it into R, and use R to make these calculations. Well, the first thing I'd want to do is I want to copy my data set. All right, so for Mac, I have to go Control-C, which I just did. Now I want to go over to R, and I'm actually going to start on the second row, and I'll explain that in just a second. And then I'm going to paste. The reason I want this up here is I want to name my variables. So when I get this into R, I have variable names. All right, so now I want to do a save as. I want to save the data set, but I want to save it something other than state or arsenic. So I'm just going to call it data 1. I need this file format to be .csv. It can't be that one. It has to be the comma separated values. And I need this saved on my desktop. All right, so I hit save. I go over to my desktop, and you can see that I have a data set, data 1, right here. Now, I'm not going to need this anymore because it's saved on my desktop. I really don't even need this anymore. What I need now is to get R and do a sequence of commands where I can get this data set into here where I can analyze the data. All right, so first thing I need to do is I need to name the data set. I'm just going to call it data. Just make sure here, tattoo this one to the brain. This is very important. Don't name your data set state or arsenic. Don't name your data set the same as one of the variable names. If you do, it gets into an error situation, creates a lot of confusion, a lot of frustration. Just don't do it. Just, again, look at the variable names in your data set. Make sure you don't name your data that. Next thing I need to do is implement what's called the read.csv file. You think the .csv has anything to do with saving as .csv? Absolutely it does. It's the command we use to get a .csv file from our computer into R. Now the next thing I have to do is put quotation marks, and then it takes a little bit of skill, but I need to take this data set, drag it over, and it has to be directly between the quotation marks. Now, let me show you what happens if I don't do that. Well, no, let me show you what happens if I do that successfully. If it's between the two quotations, I hit enter, you'll notice that I don't get a red error. As long as it's not going to give you any feedback. If you don't get any feedback, that means you implemented the command correctly. So it's all good here. But what would have happened if I'd done something like this? And I'll name it the data set difference so it doesn't give me an issue. Let's say I drag this over and I don't hit the mark. I don't get the name of the data set and the location between the quotation marks. Well, I'm going to get an error. I'm going to get a big red message that says, it was not carried out. And the reason it wasn't carried out is because it's not between the two quotation marks. The next thing I do, and this has caused so much frustration because students just don't pay attention to this particular detail, I must attach the data before I can analyze the data. I don't know how many times I'll get emails from students at 1 or 2 o'clock in the morning, and trust me, I'm not going to be up at 1 or 2 o'clock in the morning. I'll read your email the next morning around 7 or 8 o'clock. And they're like, I just can't get this R to work. Nothing works for me. And they miss this one simple command. Once we get our data into R and we name it something, in this case, I just called it data, I must attach the data. Otherwise, I can't perform a command. For example, let's try to look ahead of data, which I can do. I can view the data. So I have two variables, state and arsenic, and this head data will show me the first 6 rows. But when I come in and try to find the mean of arsenic, notice it gives me an error that arsenic has not been found. The reason it has not been found is we have not attached the data. So let's attach the data set. No red mark, so it means it was implemented correctly. And now I can start finding these measures over here. First thing I want to do is let's just go in sequence. I could do a histogram of my quantitative variable, arsenic. It's a little slow, kind of frustrating. And we can see that we get practically the same bell-shaped and symmetric distribution that we got before. Next thing I can do is a box plot. Notice we have the outliers that we had before. Next thing I want to do is find the mean. .72 as we found before. Now, notice if I type this, to you and I, mean cap M, mean lower case m, that's the same thing, right? Not to R. To R, that's like Pluto and Venus, two completely different planets. And what I would do is with R, I think in your notebook, I encourage you to get super organized. At the back of the notebook, have maybe 3 or 4 pages of nothing but R commands. So you would need to find the mean. You need to use mean. Define the median. 6.8. Define the range. We get the low value and the high value. Now, I've had students before like flip out, what doesn't give me the 9.5? One guy's all you gotta do is take 11 minus 1.5 and you get 9.5. So you also have a calculator built into R where you can make operations, perform operations. Standard deviation, 1.60 as we found before. The variance, 2.54 as we found before. The minimum value, 1.5. The max value, 11 as we found before. The IQR is 2 as we found before. And the quartiles, I don't remember how to do this. I think this gives it. No, it doesn't, does it? I think what we can do is just do summary. Yeah, summary arsenic, and then it gives us the first quartile 5.6, the third quartile 7.6, and it gives us the mean and the median and the max and the min. So we can find just about a lot of stuff that we need just using summary of arsenic. Now remember, these commands have to be based on a variable. If I do summary of data, which is what? The name of my data set, I get the same thing for arsenic. I get some interesting stuff here that I need, but for state, it's not executed because state is a categorical variable. So for something I may want to do with state, I may want to do the table command. And what that will do, it'll break down the counts, the frequencies within each state. So I have 27 arsenic data values from Arkansas, 28 from California, and 16 from Texas. All right, gang, that's all I got. We're just continuing to inch our way into learning more and more and more about describing your sample data that we use to try to make statements about a larger population. Take care.